y. So if we look at the definition of a trig function with angle theta being anywhere in our 4 quadrants, that will give us an xy value. Okay, and then r is our length of that line segment formed by that. So our distance formula tells us then that r equals the square root of x squared plus y squared. And obviously your distance can't be 0. So once we have x, y, and r, then we can identify any of our trig functions. So our sine function now is always y divided by r. And our cosine function is x divided by r. Tangent is always y over x, with the caveat that x cannot equal 0 because we can't divide by 0. Cosecant is r over y, but y can't equal 0. And then since we're into our trig functions now, our original functions flipped over. So secant is our inverse of cosine, which is r over x, where x can equal 0. And cotangent is x over y, where y cannot equal 0. Okay, so we would take 1a. We're given a point 3 or negative 3, 4, and we're asked to find our sine, cosine, and tangent. So I know that my point then negative 3, 4 is back 3 up 4. So theta is that angle that forms that line segment from my origin. So the first thing I need to find then is my r to figure out what my r is. And r equals the square root of x squared plus y squared. Okay, and so my x is negative 3, so the square root of negative 3 squared plus my y, which is 4, so 4 squared. Alright, and negative 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so I know that r is equal to 5. So then if I start with sine, and sine was y over r, right? Yes, I hope so. Yes, okay. So then I know that my sine value is equal to my y value, which was 4, over my r value, which was 5, so 4/5. Cosine is x over r, so I know that cosine is equal to my x value, which was negative 3, over my r, which was 5. And then tangent is equal to y over x. Or is it x over y? Y over x. So then my y value is 4, and my x value is negative 3, so 4 over negative 3. So there's like a lot in this. There's a lot of different things to remember about the unit circle. Alright, close that again. So negative 2, 3 would be back 2 up 3. So theta forms the angle that forms that. Right, so r equals the square root of x squared plus y squared. So my x is negative 2 squared plus my y, which is 3 squared. And negative 2 squared is 4, 3 squared is 9. So I end up with r equals the square root of 13. No. Sometimes it just helps people visualize. Alright, so I know that my r is the square root of 13, and sine is always y over r, so I know that then sine is equal to my y value, which was 3, divided by my r value, which was square root of 13, so 3 over square root of 13. Cosine is x over r, so my x value is negative 2, and my r value is square root of 13. And tangent is y over x. And so my y value is 3, my x value is negative 2, so 3 over negative 2. Okay, and so that helps us when we're given a point. Sometimes though we're not given a point and we need to use our information that tells us about when sine, cosine, and tangent are positive to help us determine the quadrant that our point lies in. When we're given what our tangent equals, but that doesn't tell us our point. Right, so we know the tangent, it tells us, is equal to -5/4, and it tells us that cosine is greater than 0. And so if something's greater than 0, then we know that it's positive, so we know that cosine is going to be positive. So we need to figure out what my x and y, tangent is y over x. So I know that I need to figure out my y and my x values for this, but this negative out front throws me off because I don't know if it goes to my y or if it goes to my x. And so that's why we use the information about cosine to tell us that. So if I go back to my graph, then I know that cosine is positive in quadrant 1 and quadrant 4. And in quadrant 1, everything is positive. My x and y are positive. But in quadrant 4, my y is negative, x is positive. So I know that my y has to be my negative value. So if I use that information, then I know that y has to be the -5, and x is going to be the 4. Because I know that, well, this tells me when cosine is greater than 0, it tells me that cosine is positive. Because any number greater than 0 is positive. And so then I know that if I go back to this table, that cosine is only positive in 1 and 4, because it's negative over here. And so if it's only positive in 1 and 4, then either my x and y both have to be positive, or my y has to be negative while my x is positive. So knowing that, then if I need to find sine, my sine is going to be y over r, but I need to find my r. And my secant is the inverse of cosine, and so my secant, see, cosine is x over r. So my secant is r over x, and that's in your notes. So first thing I have to find is my r. I know r equals the square root of x squared plus y squared. So then my x is 4, my y is -5, 4 squared is 16.
Well, there's always students like up there as well. Brittany Connor, Brooke Dyke, Sarah Holton, Brandon Connor, Gary and Twitter, Cruz, Youngall, Brett Demery, River Dyke, Robin, Helen, Jacob Oshaver, Jill Paul, Cedar Wolf, Chelsea Clifford, Dakota, please come to us for a long now, please.
Okay, and I know that the 5 squared is 25, and then 16 plus 25 is 41. So I end up with r equals the square root of 41. So then if I use that information to figure out my sine, I know that my y value is -5, and my r value is square root of 41, so sine is going to be -5 over square root of 41. Anyways, that was my rant of the day. And then I know that r is square root of 41, and x is 4. So secant's going to be square root of 41 over 4. Alright, I look at 2a, I've got sine equals 4 over 5, and tangent is less than 0. I know that sine is y over r. So then that tells me that I need to find my x value. And so to find my x value, I know that r equals the square root of x squared plus y squared. And r is 5. And I don't know what my x squared is. And I know that y is 4 squared. So I know 5 equals the square root of x squared plus 16. and then I square each side to get rid of my square root. So 25 equals positive or negative x squared plus 16. Then I subtract 16. So x squared equals 9, which then tells me x equals positive or negative 3. And I need to figure out if it's going to be positive or negative. And so in order to do that, I need to use the information that I have. Its tangent is less than 0, and any number less than 0 is negative. So I know that tangent is going to be negative. So I need to figure out when tangent is negative, what's going on with my x values. So if I go back to my table, tangent is negative in both quadrant 2 and quadrant 4. But my sine value was positive, and so that puts me just in quadrant 2. And then I see that in quadrant 2, my x is negative, so I know x has to be negative 3. Everybody follow that train of thought? Okay, so then I know that x equals negative 3, y equals 4, and r equals 5. So if I fill in my values, cosine is x over r. So my x is negative 3 and my r is 5, so cosine is negative 3/5. Cosecant is the inverse of sine, and we know that our sine is 4 over 5, so the inverse of sine is 5 over 4. We could also use our information about it being r over y. Gives me 5 over 4. Let's get 3a, I guess. I want to ask you to find your reference angles of pi, pi over 2, or 0, pi over 2 pi, and 3 pi over 2 for cosine and tangent. The easiest thing for you guys to do is going to be to use your unit circle, because we've already done all of our reference angles on our unit circle. So if I start with cosine of 0 on my unit circle, I know that cosine of 0 is equal to my y value, which is 1. Okay, I also know that cosine of pi over 2 is equal to 0. That's on your unit circle. We're just going around your 4 quadrants. Cosine of pi is negative 1. And cosine of 3 pi over 2 is 0. Because cosine is equal to your y value on your unit circle. I know that tangent is equal to y over x.
Wait, cosine equals to y.
I think so, doesn't it? Oh no, you're right, cosine's x. Sorry, I get those mixed up all the time. It goes cosine, sine, and I think it should go sine, cosine, because that makes more sense. Eventually you'll just memorize them like me, unless you run out of room in your brain. Alright, tangent of 0 is 0. Right, Mark, are you going to correct me? Is it 0? Yes, okay, I'm stealing this. Because that way you can't correct me. Cosine of pi over 2 is undefined. Tangent, man, my brain's not working today. And this is on recording. People are going to think I'm not very smart. Tangent of pi is 0, and tangent of 3 pi over 2 is undefined. And it just asks you to find those because those are going to be like your major reference angles for when you're graphing. So it's kind of important that we know where those are for when we graph at some point. So you guys will know how to do that based on your unit circle stuff that we've already done. And then the last thing that we're going to do is we're going to look at reference angles. And reference angles is the angle that it takes for you to get to pi. Okay, it's the angle that it takes for you to get to your x-axis, basically, to get to pi or to get to 90 degrees or to get to your x-axis. So it's whatever we have to add or subtract from your angle to make it be right on the x-axis or 90 degrees. Oh, you can use a different symbol if you want to. Theta? Theta is just the Greek symbol they usually use for an angle, but you could put like A or B if you wanted to. They use like, oh yeah, no, you don't have to. I know that that's what it is, so I just leave it off sometimes. It saves time if you just leave it off sometimes. Okay, so it's either whatever you need to get to this axis, this side of the axis, or this side. It doesn't matter which part of the x-axis you get to, but you have to get your angle to the x-axis. So sometimes you'll have an angle that'll go, I'll use black, like all the way to like here. So then you're only finding this as your reference angle. Okay, so it's whatever it takes just to get to your x-axis, whether it's on the left side or on the right side. Does that make sense? Okay, I hope so. Okay, so if I look at 4A, I'm starting with an angle of 300 degrees, and I need to find my reference angle. And my reference angle either gets me to 180, or it gets me all the way around the circle to 360. Okay, when we're dealing with degrees, you're either dealing with 180 or you're dealing with 360, and we never work backwards. So I know that an angle of 300 is going to be somewhere like right here, because it's going to be mostly around my circle. So I need to figure out what my reference angle is to make it be 360. And so I'm going to take 360 minus that 300, which gives me an angle of 60 degrees. So for 300, my reference angle would be 60 degrees. Okay, if we look at 2.3, 2.3 is dealing with radians. So when dealing with radians, you're either looking for pi or you're looking for 2 pi. You're either trying to get to pi or to 2 pi because that's what you deal with when you're dealing with radians. So if I'm dealing with 2.3, and you don't always have to draw these out if you just know where it's at, but in this case 2.3 is about right there. So since 2.3 is about there, I need to figure out what I need to do to get to my x-axis, my closest x-axis. And so when dealing then, in this case, we're going to be dealing with pi because we're only going halfway around the circle. So I'm going to take pi minus 2.3. And pi is approximately 3.14. So 3.14 minus 2.3. What does that give me? .84. So I get approximately 0.84 radians to be my reference angle. All right. And then the last one is negative 135 degrees. Like I said, we're always working forwards. And so, let's see, negative 135, there's 90, so negative 135 is somewhere right there. Okay, so then if we want to figure out what we need to get to my x-axis, well, in this case, I'm going to be working with 90 degrees versus 180, because 180 gets me all the way around the circle, and I'm only trying to go halfway around the circle. So I need to figure out what 90 degrees minus that negative 135 degrees is. So minus negative becomes a plus, because you're always taking whatever minus. And so what's 90 plus 135? 225. So my reference angle in this case is 225. So you're always taking like 90 degrees or pi or whatever minus whatever angle you already have. Okay, so I know that was a lot. You guys are going to work on this over the next 2 days, so we're going to work on it tomorrow too. So page 316, 9 to 12, 23 through 30, and 37 through 52.